Hi guys, we're going to be talking about critical points in Extrema today on graphs. And critical points in Extrema actually help out quite a bit because in your next math class, calculus, critical points in Extrema will actually tell you some critical things about the derivatives, the antiderivatives, and the second derivatives that you might have to do. So this is really kind of cool and essential for for higher up math classes. Alright, you're already at the extreme point of it. So once again, our old buddy, Desmos, we're going to go back to it and just talk about these points and just work with everything. Alright, so some pretty typical ones, maximum, local max, local min, that type of thing. Okay, x cubed. Alright, so this would be a max, and we would actually say the point 0, 0 is the max. Okay, now if I had gotten rid of the negative, it would now become a minimum. Okay, and it'll be a global minimum, okay, and it would be a point of inflection, because if you take a look at it, our values of y are decreasing but at a slower rate, because the closer we get to 0, it's decreasing at a really slow rate, and then once we get to 0, all of a sudden they're increasing from 0 on the way up, and they increase faster and faster. And so this just tells a little bit about parabolic flight and stuff. So it's kind of cool how it works. Okay, so let's make this x cubed minus 3x squared. There we go, something funky like this. Okay, so points of inflection. Now, if you just click on them and just work with them as is, you're pretty good to just find the points of inflection. So if you like highlight on here and it shows up, that's probably a point of inflection, a point of notice, okay? So we already know about x-intercepts and everything, okay? And that actually tells some cool stories about this. Well, shoot, I'm just going to superimpose it. I'm going to teach you a little bit of calculus. Y equals 3x squared minus 6x. Yep, there we go. Okay, so this is some kind of cool stuff. Okay, all right, so here is the regular function in black, and in red the derivative of it. And the derivative is found just by doing the power rule if you want to learn about that in calculus. But anyways, as you can see, as my regular graph comes up and it touches the x-axis, it's going from increasing, it's going from positive to decreasing values. Okay, and if you look at my actual graph, if you zoom out a little bit, it's going from positive values to negative values, so it crosses over. So this one will actually tell you the acceleration. Now here at this point, about midway in between, it's kind of hard to see with the graph right here. It's probably, you know, something that looks like this. It's going to be probably lined up with -1. Yep, so it is. Okay, so if we take a look at negative or +1, -2 on this graph, it's going to be lined up with this one. Okay, and so all of a sudden the red graph is it's decreasing, and it goes below the x-axis, and then it hits its lowest point at 1, and then all of a sudden it starts increasing. Well, if you take a look at the black graph, and what it's saying is we're decreasing, and then all of a sudden we stop. We don't hit the we hit the x-axis, but then all of a sudden we go decreasing even faster, and then all of a sudden we start slowly going negative, and we start going positive, and we start going on our way up. And that's the turning point right here, is at 1 we start turning. So it's actually, that's called a critical juncture right there. So it's really kind of cool to see where this stuff goes. Okay, so that's what we're talking about, and some interesting stuff. Now, I do want to talk to you about this because we can talk about the nature of graphs a little bit. Okay, if you notice, this has a degree of 3, yet I only crossed this graph twice. And you're like sitting there going, wait, shouldn't I get at least 2 answers here? And yes, you should, because if you were to factor this, you would have x squared parentheses x minus 3. Okay, so one of your zeros would be the x minus 3. So one of my zeros would be the positive 3. Okay, but then all of a sudden I would have 2 zeros because I'm squaring, and that means that 2 zeros would be an answer, but we only count one of those. So technically this is 3 real numbers, but 2 of them are the same, so we only count that once. We would say that at this point it has a multiplicity of 1. In other words, there's 1 3 that appears, and yet at this point it hits it once with the hump. I like to call it the multiplicity is what it's actually called, but I like to say, okay, the hump hits at once, it hits it twice when it's like this type of hump. Okay, so that's where the 2 zeros come into play. Okay, so that's how you get the 3 actual real root answers, okay, that you learned in Algebra 2 when you were going through polynomials. Okay, so that's some things to really think about when you're working with this. Now these would be local max and local min right here that you would focus on, whereas if I made this, let's go x to the 4th plus, there we go. Okay, now right here I would have a local max, a local max, a local min, and this would be a global or global minimum right here. So I could actually look at that value and tell you what it's going to be. Okay, now factoring that one, not as easy. I'm not going to do it, but you guys can actually see some really cool stuff when you go graphing through here. Okay, so once again, when you're looking at this, what it's doing is you can actually get some really cool ideas about this. Now if I were to make this a derivative, plus 3x squared minus 6x. Okay, you could see a lot of pictures going on here with this one. Okay, so for example here, let me click off of the, nope, did not want that. Boom, boom. Okay, as you can see, I go, these two values actually have the same, so I'm going from a decreasing rate, and then all of a sudden I start increasing. That's why this value goes from negative to positive, and then all of a sudden here I stop increasing, and that's usually about halfway in between these two. Okay, so it's at -1, and there it is. Okay, and so then I work my way over here, and now I'm slowly decreasing in my speed. Okay, and then all of a sudden I go through here. I mean, you can just tell a very pretty picture, and later on you guys don't need to know this for this test, but I wanted to show you where this stuff comes from and where it comes into play. Okay, so it's really kind of cool how it works. All right, thank you guys very much, and that's it for critical points and Extrema. You guys have a wonderful day. All right.